right, welcome back. Here's part 2. All right, 13. If you guys look at the printable answer key, when we did this one in class, there is a constant. It's that fraction. So I'm going to go ahead and loop this problem. So again, since I loop, the base of the exponent is the base of the log. And I'm just going to loop the other direction. So 16, behind the 16 goes my fraction. And then that's going to equal my exponent when I'm done. If you have the alpha math option on your calculator, you can just push that in your calculator, scroll left to right, put in 16, put in your fraction, but most of us will probably have to do the change of base formula, which is also at the top of your formula page. The main thing is when you type this in, your calculator will start the parentheses, you will need to close them. So that will equal, whenever I'm done with it, 9x plus 3. So as it turns out, that in my calculator is negative 1.5, which is 9x plus 3. To get x by itself, I'm going to subtract 3, which gives me negative 4.5. And then to divide, or get x by itself, I divide by 9, and when I'm done, my answer is negative 0.5. All right, 14. 14 has a constant, whether you look at the 3 as a constant or the 15. But before I can loop it, it's got to be just the log. So I will have to move the 7 and the 3. The first thing I'm going to do is move the 3 by adding it, which gives me 18. And then to move the 7, I'm going to divide it, which I'm just going to leave it as the fraction. I'm not going to turn it into a decimal. And now I'm ready to loop. And when I loop it, I'm going to loop it into an exponent. So it's going to go 5 to the 18, whoops, hold on, 5 to the 18/7th power, and that will equal x. So once I type that into my calculator, the answer I end up getting is 62.712. So there's my answer for 14. All right, let's go to 15. 15 does not have a constant, so I do not have to loop this. Instead, since one log's on one side and one log is on the other, just like I can cancel out the bases of exponents, I can cancel out these logs and focus on what's left. So I'm going to subtract 2x to get the x's by themselves. And when I'm done, there's my answer. X is just 5. All right, 6 more to go, and then the graphing will be up for you guys tomorrow. So 16 is similar to the one that we just did. There is no constant, but I can't just cross out the logs yet because I don't have just 2 logs. So when you guys see that first condense, what I need for you to do is condense the left side down into 1 log. So again, just ignoring the logs. I'm going to bring the 1/2 back as an exponent. That subtraction will be turning into division. And then I can bring the log back. And then I still have the log from the other side. And now that it's just 1 log on one side, 1 on the other, I can ignore the logs. So kind of move it up here. I'm just going to write what I currently have. And as I told you guys in class, if you have fractions, the easiest way to solve is with cross products. 3 times 2 is 6. 1 times x to the 1/2 is just x to the 1/2, which is like the square root of x. And to undo the 1/2 or the square root of x, I'll take it to the second power, which means I'll take 6 to the second power, which gives me my answer of 36. Okay? All right, so 17 does have a constant. It's this one. But before I can loop it, I need 1 log, which means I'm going to have to get the left side to become 1 log, which is why you guys see the condense. So again, just ignoring the logs temporarily. I'm going to look at this as x plus x minus 2. Those parentheses are protecting the log. That plus is going to become times, so I will distribute that x through. And now I'm just going to put it in parentheses. I'm going to bring the log back that I've been ignoring, and the 1, and now I'm ready to loop. So as I loop, it goes 3 to the first power equals, and then the x squared minus 2x. Now in this problem, because we have two types of x's, you need to bring everything to one side because we will have to factor. So that 3 to the first power, which is 3, I'm going to bring over to the other side. You can make your factor box a times c, so 1 times -3 is -3, and put b here. So my factors of -3 that add up to -2 are -3 and 1. And I can set up my parentheses, x minus 3, x plus 1. And when I'm done, my answers will be 3 and -1. So going back to 17, there's your answers, 3 and -1. 18, there's a constant, the 1 or the 4. It doesn't matter which one you look at, but I will have to loop. But before I can loop, again, it's just the base and the exponent, so I need to move the 1 and the 2/3. First, I'm going to move the 1 by subtracting it, so that gives me 3. And then I'm going to move the 2/3 by multiplying by the reciprocal. Again, I'm just going to leave this as a fraction. The left side is now just the base with the exponent. And I'm going to leave the right side as 9 over 2. And now I'm ready to loop. And since it's an exponent, it's going to loop into a log. So the base of the exponent is the base of the log. So it's going to go e to the 9 half equals 4x. Just like before, I can cross out the log e and replace it with ln and just type that into my calculator. So if I type in ln of 9 halves, I get, 9 halves or 4.5, I get this decimal, and that will equal 4x. And now to get x by itself, I just divide by 4, and I get 0.376. So there's my answer. All right, 3 more, and then we're done. All right, 19, there is no constant. So what I need to do is get my bases of 25 and 125 to be the same. So I'm going to go back to my cheat sheet. And this time, I'm going to look for a row that has both 25 and 125. And I see that in this row. So I can turn both of these bases into a base of 5. So 5 to the second power is 25. And that's still 25 to the x minus 1 power. And then 5 cubed is 125, and it's 125 to the 4x power. But now that my bases are the same, I can ignore them. I'm going to distribute my 2. 3 times 4x is 12x, and now I'm going to work to get x by itself. I'm going to subtract the 2x over, and I'm going to divide by 10, so my answer is -2/10, -1/5, -0.2, whichever you prefer. 20. There is no constant, so I will not be looping. Instead, I'm going to try to work this like problem 19 to get one log on one side, one on the other. But before I do that, I will have to condense the left side. So I'm going to take my 2 and write it back as an exponent, and my 1/4 and write it back as an exponent. And then that subtraction is going to turn into division. So I'm going to write it as 100 over x to the 1/4. I'm going to bring the log back from the side that I just ignored. And now that it's 2 logs with the same base, one on one side of the equal sign, one on the other side of the equal sign, I'm going to ignore them. And now just focusing on what's there. Again, if I have fractions and I'm asked to solve, I'm just going to do cross products. So 100 times 1 is 100. 50 times x to the 1/4 is, well, 50 times x to the 1/4. To get x by itself, I'm going to divide by 50. And to get rid of the 1/4 power, which is like a 4th root, I'm going to take it to the 4th power on both sides. And 2 to the 4th power will give me my answer of 16. All right, last problem. There is a constant. Again, constant means you will loop. But before I can loop, it's got to be just the log. So I have to move the 35 first. So I'm going to divide it to the other side. And I'm just going to, again, I'm going to leave it as a fraction. It's just less work. Now I'm ready to loop. As an exponent, it goes 6 to this 18 over 35 exponent will equal my answer of x. And if I just type in that base with its exponent, I get 4.53. And there you go. There is the solving part. That's it.